Hello everyone. Good afternoon to all. Hello JNB Karimnagar. You are here. Very good. Last class we were not there now because I was starting. I started the class lately with delay. Okay. So my voice is clear to all. Is my voice clearly audible to all guys? And also my screen is visible clearly. Yes or no? Just respond to the chat box. Everyone, just respond to the chat box whether my voice is clearly audible to you or not. Hello, admin. Guys, do one thing. Just rename your JNB name. Huh? With which ID you have joined, just rename it. Write it in your by your JNB name. It will be good. Okay. Okay. So, yeah, hi JNB. Yanam. Okay. So in the previous class, we have discussed the Pascal triangle, right? Pascal triangle and how we can evaluate the coefficient of binomial expansion by using the Pascal triangle also we have discussed in the previous class. And also we have seen factorial notation and some formula of combinations also we have discussed. And then we solved one JEE Mains 2022 previous year question. That is the answer is 102. Already we have discussed it. So today we are going to start our main topic, that is binomial theorem. Okay, guys. So I can say, guys, actually in perspective of JEE Mains, basically from one or two concepts of binomial theorem only questions will be coming maximum times from general terms. Asking in JEE Mains, it is asking find the coefficient of some term, find the middle term, find the greatest term. All these things are coming in mains level questions. So what are the questions are coming in JEE Mains, they can be solvable by you if you are understanding all the concepts very clearly and solve all the previous year question papers and solve a lot of the mains level questions also, then you can easily solve. Those questions will be coming in JEE Mains examinations, right? So okay, so let's start. What is binomial theorem? Okay, so let's see. Suppose if I'll ask you to write the formula or the expansion of a plus b whole square. So you can easily write this. This is our a square plus 2ab plus b square, right? So what are the coefficients? What are the binomial coefficients present in this? We can write this as by using in Pascal triangle. Already we have discussed na, the coefficient of a square is 1 into a square plus 2 into ab plus 1 into b square. So this one, you can see here, this one is nothing but nc0, and these two, sorry, n here, what is n? N is actually 2. This one is 2c0 and this 2 is 2c1. This one is also 2c2, right? So these are my binomial coefficients. So all these coefficient of binomial expansion can be replaced by the combinational formula also. 2c1, 2c0, 2c2. They are called actually my binomial coefficients. They can be written as in this form also by using the formula of combinations, or they can be denoted by combinational formula. Okay, is that clear to everyone? Similarly, if I'll ask you to write the formula, write the expansion of a plus b whole cube, है ना? So this will be a cube plus 3a square b plus 3ab square plus b cube, right? So here you can see the coefficient of a cube is 1, coefficient of a square b is 3, and coefficient of ab square is 3, and coefficient of b cube is 1, right? So 1, what is 1 here? 1 is actually my in 3c0, 3 is 3c1, 3 is here 3c1 also, and this one is 3c3, right? So by this way we can represent all the binomial coefficients, right? So similarly, if I'll ask you to write, the expansion of a plus b to the power n, a plus b to the power n. So in this expansion, total number of terms will be n plus 1 number of terms, right? N plus 1 number of terms, and each term has degree n, right? Okay, and each term has degree n. Okay, so you can observe here what is happening actually. See, in a plus b whole square, we are writing first NC 2c0 a square, 2c0 a square, 2c0 a square into b to the power 0, right? Then 2c1 a to the power 2 minus 1, है ना? So power of a decreased by 1 and power of b increased by 1 in the second term, and in the third term what is happening? 2c2, again power of a decreased by 1, that is 2 minus 2, that is 0, and again power of b increased by 1, that is 2. This pattern will be followed by with all the binomial expansion when you will be doing. So similarly here also you can do a plus b to the power n. What we can do? So we can start with nc0 a to the power n into b to the power 0 plus nc1 a to the power n minus 1. The power of a decreased by 1 and the power of b increased by 1, b to the power 1. Similarly, nc2 a to the power n minus 2 p to the power 2. Similarly, plus nc3 a to the power n minus 3 b cube, and so on up to ncn a to the power 0 into b to the power n. So actually this is the binomial expansion of a plus b to the power n, where n is the non-negative integer. Okay, we are discussing about, first we are discussing about the non-negative, when the index is non-negative integers. Okay, so a plus b to the power n is equal to nc0 into a to the power n b to the power 0, nc1 a to the power n minus 1 b to the power 1, nc2 a to the power n minus 2 b to the power 2, up to so on ncn a to the power 0 into b to the power n. Is that clear to all, guys? Clear? Okay, so if it is clear, this is the binomial expansion of a plus b to the power n. Now this is my first term. You can see, you can say this is my first term, this is t1, this is my second term, this is t2, this is my third term, this is t3, and this is my fourth term, this is t4, and this is my nth term, this is tn. Is it or not, guys? Is it or not? So total number of terms is n plus 1, right? So guys, can I write this t1 as, this t1 as t 0 plus 1. Because see here, always the degree of all the terms, each term has degree n. See, each term has degree n or not? A to the power n into b to the power 0. Degrees n, a to the power n minus 1 into b to the power 1. Degrees n always. So always if you add the index of a and b, or if you add the power exponents of a and b, then the sum will be n always. Okay, the sum will be n always, right? So this t1 can be written as t0 plus 1 plus this t2 can be written as t1 plus 1, yes or no, plus this t3 can be written as t2 plus 1, t4 can be written t3 plus 1, and so on. Tn can be written as tr plus 1 or tn minus 1 plus 1. I can write this as tn minus 1 plus 1. Okay, clear? Okay. So this, okay guys. Okay. So in generally, why we are writing T1, T2, T3 and T4 are in this way? Because we need to find the general term of the binomial expansions. So what we are doing, if I'll ask you to find the general term TR plus 1, okay, if I'll ask you to find the general term of the binomial expansion, what it will be, guys? What it will be? That is NCR a to the power n minus r into b to the power r, right? Where r is lying between 0 and n. Okay, so this is my general term of the binomial expansion, right? See, T1 general, why I am writing TR plus 1? Because see, if you are asked to find the T4 fourth term of the binomial expansion a plus b to the power n, then this will be your fourth term, yes or no? This will be your fourth term. So TR plus 1. So where r is equal to suppose in binomial, okay, I am asking here T4, what is T4? Find T4. So by use this formula first. So T3 plus 1. So R, the value of R is here 3, right? R is 3. So NCR, that is 3. NC3 a to the power n minus 3 into b to the power 3. So this is my fourth term of the expansion a plus b to the power n. Can you check it, please? Yes, NC3 a to the power n minus 3 b to the power 3. Yes or no? So that's why this is the expansion, or this is the general form. This is my general form of the binomial expansion. General term. Remember, this is important. Okay, general term of the binomial expansion a plus b to the power n. So I am writing here again. So this is the binomial expansion. Okay, and the general term is, I am writing here, general term is TR plus 1, that is NCR a to the power n minus r into b to the power r. So this is my general term. Okay, and what is the sum? What is the sum? What is the sum? Or we can write it is in the series form, that is a plus b to the power n can be written as summation from r is equal to 0 to n NCR a to the power n minus r into b to the power r. So this is my general form of the binomial expansion a plus b to the power n. And general term क्या है? What is general term? General term is tr plus 1, that is ncr into a to the power n minus r into b to the power r. Remember these two formulae, they are very, very important. Okay. You can note down also, and you can take a screenshot of all these things. Okay. Sure. If this, I hope this is clear to all of you guys. Is there any doubt? Is there any doubt? No doubt. Jenbi Karimnavar, Jenbi Sanglang, Jenbi Nalgonda, Jenbi Anam. Okay. Thanks for your participation. All of you, please respond whether it is clear to all of you or not. Okay. I hope this is clear. Chalo, let's move. Now, binomial theorem, total number of terms. That is, if I will consider the binomial expansion as a plus b to the power n, then the total number of terms is n plus 1, and the binomial coefficients are nc0, nc1, nc1, nc2 up to ncn. The index of a decreases from n to 0. Yes or not? The index of a nc0, a to the power n, b to the power 0, plus nc1, a to the power n minus 1, b to the power 1. So nc0, the index of a decreases from n to 0. Similarly here nc2, a to the power n minus 2 into b square up to ncn, a to the power 0, b to the power n, and index of b increases from 0 to n. Okay. And in any term, sum of indices of a and b is n. You can see here, sum of indices of a and b is always n, right? Sum of indices of a and b is always gives you n. You can observe here also, if you'll add the indices of a and b, then you will be getting the sum as n. Actually, in Odisha, now the temperature is very high. It's now, the minimum temperature is now, it's 43 to 43 degrees centigrade. Okay. I'm from Odisha, huh? And temperature is very high, and also humidity is also very high. Okay. Chalo. ठीक है. So this is all about your binomial theorem. Now, the coefficients, there are two terms, the two things are left with. The coefficients are equidistant from the beginning and n are equal. Okay. The coefficients are equidistant. The coefficients equidistant from beginning. Suppose if I'll take the rth term from the beginning, it will be equal to the n minus rth term from the end. Right? Okay. So ncr is equal to nc n minus r, and this is the last thing, that is kth term from the end is equal to n minus k plus 2th term from the beginning. Suppose if you'll consider the expansion, suppose I am considering a plus b to the power 9. So there are total number of terms is 10 terms we are having. So if you'll consider, the terms are t1 plus t2 plus t3 plus t4 plus t5 plus t6 plus t7 plus t8 plus t9, yes, plus t9 plus t 10, right? Okay, so these are my 10 terms starting from t1 to t10. Okay guys, so what it is saying now, kth term from the end is equal to n minus k plus 2th term from the beginning. Okay, suppose I am taking third term from the end. Okay, suppose I'm taking k is equal to 3. Okay, if I'm taking k is equal to 3, means third term from the end, that is third term from end is T8, right? Which is, by our result, it is saying which is equal to n minus, n is 10, 9. N is, what is n? N is 9. So 9 minus k, k is 3 plus 2, right? Term, that is 9 minus 3 is 6 plus 2, 8. So 8th term from beginning. You can check 1, 2, 3, 4, 5, 6, 7, 8. So it is third term from the, it is third term from end is equal to 8th term from beginning. Clear? Is it clear? The last result, it is clear to all of you guys? Understood or not? Clear? Yeah. Easy, you know? Okay. If it is clear to all, let's move to one question. Okay. Oh, 2022 JEE mains question. It is asking if the coefficient of x and x square in the expansion 1 plus x to the power p into 1 plus x to the power q, where p and q is less than equal to 15, are minus 3, minus 5 respectively, then you need to find the coefficient of x to the power 3 is equal to, you need to find the coefficient of x cube, right? Okay, so just I am writing, see the solution, and you can try with me also. The expansion is given as 1 plus x to the power p into 1 minus x to the power q, right? Okay, so if you'll write the general form of these two expansion, it will be summation from r is equal to 0 to p, okay, pc0, okay, so pc r 1 to the power r, that is 1, and x to the power p minus r, right? Sorry, a 1 to the power p minus r, that is 1, and x to the power r, okay, into summation r is equal to 0 to q, qc r 1 to the power, similar thing na, minus 1 to the power n minus r into x to the power r. Okay, so we can write this as also summation r is equal to 0 to p pcr x to the power r into summation r is equal to 0 to q qcr minus x to the power r. You can write na, no issues. Yeah, okay. Now if you'll open these two summation, if you'll open these two series, what you will get? Just open these two bracket or do two summations, what you are getting, let's see. So if you'll open it from r to r is equal to 0 to p, so pc0 x to the power 0 plus pc1 x to the power 1 plus pc2 x square, okay, and so on up to pcp up to x to the power p, right? Into second expansion is qc0 into x to the power 0 minus -1 to the power. Okay, so if you'll take r is equal to 1, this will be minus qc 0 x to the power x, and then plus qc1 x square, and so on up to p qc r na. Yeah, qcq x to the power q, right? So this is my expansion of the second summation. Is it or not? qc 0 x to the power 0, qc 1, this is 1, this is 2, huh? Sorry. Okay, now tell me, this is -1 to the power q, you can write here. Okay, now tell me, we are given, guys, in the expansion, in the question it is given that the coefficient of x is -3 and the coefficient of x square is -5, right? So now try to multiply. Now try to multiply these two brackets and try to find first the coefficient of x. So if you'll find the coefficient of x, that is here we have x to the power 1 and here we have x to the power 0. So from by multiplying these two, we are getting the coefficient of x also, right? Coefficient of x, that is pc1 into qc0, right? pc1 into qc0, एक तो ये हो गया, and also x, these two can be multiplied, x square, x to the power 0 and x to the power 1, that is pc0 into qc1 minus qc1. These two are the coefficient of plus, coefficient of x, which is given as -3, है ना, which is given as -3. That is coefficient of x. ठीक है, if we'll solve these two, if we'll find this pc1 is p, qc0 is 1 and pc0 is 1, minus q is equal to -3, that is from here we can write p minus q is equal to -3, right? Suppose this is my equation 1. Clear? This is my equation 1. Now try to find if we'll take this to the next thing. Okay, suppose, see, now try to find the coefficient of x to the power 3, that is we can multiply pc0, these terms, x to the power 0 into x cube चाहिए ना मुझे, x square और x cube, yeah, x square, right? X square. So x to the power 0 into x square, that is pc0 into qc2. Okay, then x to the power 1 into x square, x to the power 1 into x to the power 1. So pc1 into minus qc1. Okay, plus these two also we can multiply, that is pc2 into qc0, which is given as -5, which is coefficient of x square. Is it or not? So if we'll solve this, or if we'll find the value, that is qc2, pc0 is 1 QC2, PC1 is P minus Q minus PQ. Is QC2 plus, sorry, minus PQ plus PC2. PC2 is equal to minus 5. If you'll solve this, or if you'll use the formula of combinations, we'll get Q factorial upon, this is actually 2 factorial into Q minus 2 factorial is equal to, this can be written as, you can write this as, and finally we'll be having, I'm writing directly the answer. You have to calculate all these things. Just I'm writing the answer, that is Q into Q minus 1 upon 2 minus PQ plus P into P minus 1 divided by 2 minus 5. Right? So from the first results we already have, that is P is equal to, here we got P is equal to Q minus 3, right? P is equal to Q minus 3. So here if we'll use P is equal to Q minus 3, then this become Q into Q minus 1 upon 2 minus PQ plus Q minus 3 into Q minus 3 minus 1 upon 2 is equal to minus 5. So by solving this, you will get all the terms now. Now you can see, you can observe here, all the terms are in terms of Q. So by solving this equation, you will get Q is equal to 11. And after getting Q is equal to 11, P becomes 8. Right? So you got the value of P and Q. Guys, something is happening. Low system resource may affect audio quality. My voice is clear, guys? Yes. Is my voice clear to all? Hello. Just wait, actually, I think for the heat only. I'm switching up my camera also. Now I'm sharing my screen again. I think it is visible now, guys. I think it is visible now. Yes. Guys, it is visible now. Why it is slow? Very slow. It is showing very slow. just a minute. Okay. So you got the value of P and Q, right? If you got the value of P as 11, sorry, 8 and Q as 11, right? So if you got the value of P and Q, now you can easily, the expansion becomes 1 plus x to the power P is 8 and 1 minus x to the power Q is 11, right? So write the general form or write the series form of these two expansion, that is summation from R is equal to 0 to 8 C0 x to the power 8. Is my voice clear to all of you or not, guys? My voice is coming to all. Okay, so 8C0 x to the power 0 into summation R is equal to 0 to 11 C0 x to the power R, or we left with minus 1 to the power R. Okay, okay. So now guys, now you can easily calculate. We need the coefficient of x cube. So x cube can be written as 1 into x cube. This is also we can rewrite as x into x cube. Sorry, x into x square. Also we can write that x square into x, right? Also we can write it as x cube into 1. So all these possibilities are coming. Okay, so now if we'll apply these all these possibilities here, so to R2 sorry, this term to be 1, the first term to be 1, so what should be here? 1 के लिए क्या होना चाहिए? That is 8C0 already x to the power r, this is x to the power r. Okay, 8C0 x to the power r, we need only the coefficient. So 8C0 into 1. So when r becomes 0, then the coefficient becomes 11 minus 11 C0. Okay, minus 11 C0 plus then x cube. Okay, x cube. Sorry. This 0, this is 0 na. First is 0, r is equal to 0, then it becomes 1, then r is equal to 3. R is equal to 3 के लिए this becomes 11 C. This is r, huh? This is r. This is also r. Okay, 11 C3 into minus 1. Okay, plus x. This first sum to be x और first second term to be x. x होने के लिए क्या होना चाहिए? That is r should be 1. तो 8C1 into 2, r is equal to 2, so then it will be 11C2, right? Plus third is r is equal to 2, that is 8C2 x to the 8C2 into, that is x, r is equal to 1, that is minus 1 into 11C1, right? Plus x cube, the first term need to be 3, so r is equal to 3, so that is 8C 8C3 into 11C0. So if you'll calculate all these combinations, then you will get the answer as 23. The coefficient of x cube will be 23. Okay, so I hope this is clear to all of you guys. Actually, my pen and tab is not working. This becomes very slow actually. I don't know why. If I'll stop the class, then it will actually for the heat. I think for heat only it is happening. I don't know what is happening. Oof. Sorry guys. Okay, so come to the next thing. Come to the next question. In the next question, it is asking the coefficient of x cube. The coefficient of x cube in the expansion 1 plus x plus x square, 1 plus x square plus x cube whole to the power 6, right? In power of x. So you need to find the coefficient of x cube. So this can be written as also 1 plus x, and if you take common as x square from these two terms, so what will happen? So x square, then x plus 1 plus x, na 1 plus x. Okay, 1 plus x whole to the power 6. So now if you take 1 plus x as common, see 1 plus x as common, then what you will be having? You will be having 1 plus x square whole to the power 6. Is it or not? Now we can individually write also 1 plus x to the power 6 into 1 plus x square whole to the power 6. Now you got two expansion, binomial expansion. Now you got two binomial expansions, right? So we can write this as in the summation form. We can write this as summation from r is equal to 0 to 6 cr x to the power 6 x to the power r into into summation r is equal to 0 to 6 c r x square to the power 6 x square to the power r, right? Okay. So in the first series or in the first expansion, can you say what are the powers you are getting? What are the exponents of x you are getting? If we will open it, we will get x to the power 0, x to the power 1, x to the power 2, x to the power 3, x to the power 4, x to the power 5, and x to the power 6 we will get. Yes or no? Or in the second expansion, what you will be getting? You will be getting the power of x to the power 0. And when we will put x to the x is equal to 1, you will get x square. When you will put x is equal to r is equal to 2, you will get x to the power 4. Then if you put x is equal r is equal to 3, you will get x is equal to x to the power 6. Then x to the power 8. Then x to the power 10 you will get. Then x to the power 12. So all these powers you will get in the second expansion, right? So but we need to find the power of x to the power 4. So what are the possibilities? to get the power of 4, that is 1 into x to the power 4. This is my first case. Second case, x into x cube. If this is x, then this should be x cube to become x to the power 4. So this, or another case is x square into x square. Third case, and x to the power 4 into 1. And next case is x cube into 1. Right? X cube into x, sorry. So how many cases you are getting? That is 1, 2, 3, 4, 5. So 5 cases you are getting. Okay, if you are getting 5 cases, then tell me, so this should be 1, x to the power 1. Sorry, this should be 1, this term should be 1. Then what is the coefficient when x to the power r is equal to 1? Then when r is equal to 0, then the coefficient of x to the power 0 is 6c0 into x to the power 4. When r is equal to 2, that is 6c2. 6c2. Okay. When r is equal to, then power of x becomes 4. Okay. So then 6c2, 6c0 into 6c2 plus x into x cube. X into x cube, that is 6c1 into x cube, x square to the power r. For what value of r, x square becomes x cube? No, it is not possible. So there is no power. This is not a case. We will not consider this case. Then x square into x square. Yes, this will be 6c2 into, if r is equal to 1, this becomes x square. So 6cr, 6c1 plus third case, x to the power 4 into 1. Now x to the power 4 is possible for r is equal to 4, but 1 is not possible, because for r, for what value of r, x square becomes 1. X square becomes 1. Is it possible? If r is equal to 0, yes, it is possible also, na? 6c4 into 6c0. 6c4 into 6c0, because r is equal to 0, x square becomes 1 also. So 6c0 plus 1, 2, 3. Okay. Plus x to the power 4 into 1. Okay. X to the power 3 into x. So x to the power 3 into x. So x to the power 3. It is possible when r is equal to 3. Then this becomes, coefficient becomes 6c3. But when this becomes 1, so this becomes 1. It is possible. It is not possible to. It is not possible for any values of r. X square to the power r becomes x. So it is not possible for any non-negative integer values of r. It is not possible x square to the power r to be x. So it is not possible. This is not a case also. So these 3 cases we are getting actually. These 3 cases we are getting, and the final answer will be, after solving all these combinations, final answer will be 120. So this is your answer. Okay, guys, this is your answer. This is a very good question, came in 2022 JEE mains also, right, guys? Okay, and this is done. I hope this is clear to all. This is done. Clear? Okay, next question. Next question. This is for your homework question. Write at your home or at your room also. If the coefficient of x square and x cube are 0 in the expansion of this, okay, expansion, I am writing it again, 1 plus ax plus bx square plus bx square into 1 minus 3x whole to the power 15 in power of x, then the order pair AB. You need to find the order pair AB. This is for your homework, huh? And it's a very easy questions. I hope this can be solved by you. Okay. And Next we already studied about what is general term. General term is T R plus 1. I'm writing in big, very big font, right? T R plus 1. Now we can now the internet is used, or what happened I don't know, the system becomes very slow. The general term T R plus 1 is equal to NCR A to the power n minus R into B to the power R. This is my general term. Remember everyone, this is my general term. Okay, and this is for your homework question, guys. By use the previous formula, general term. Use the formula of general term and find the fourth term in the expansion. Find the fourth term in the expansion. 2 upon x plus x to the power log of x whole to the power 6. Okay, if the fourth term, okay, it is given as if the fourth term T4 of this expansion is 20 into 8, then you need to find the value of x. Wow, very good question. You should try at your home, in your home also, guys. And this is for your homework. You can note down your questions also, and you can take a screenshot of this question. Okay, these two questions. This is the question 1 plus ax plus bx square into 1 minus 3x whole to the power 15. Okay, and in these questions it is given that the coefficient of x square and x cube are 0. Then you need to find the order pair AB. And in the next question it is given that if the fourth term of this expansion is given as 20 into 8, then you need to find the value of x. And in the next class we'll be starting, or we'll start from middle term or greatest term. How to find the middle term of a binomial expansion, greatest term of a binomial expansion, and what is the binomial theorem for any index, we'll study. Hana? This is the binomial, this is the theorem, this is the binomial theorem on what we are discussing, that is the index as non-negative integer, right? Non-negative integers only we are discussing, or we are solving the questions on this theorem only. But next class we'll study about the binomial theorem for negative index, binomial theorem for any index also we'll see, multinomial theorem also we'll be covering in the next class, right? So till then, bye bye, take care everyone, thank you all. चलो अच्छे से रहो भाई. एंड ये जो 2 क्वेश्चन में दिया हूं होमवर्क क्वेश्चन ना, ट्राई टू सॉल्व दीज 2 क्वेश्चंस before coming to the next class. I hope all of you will be solving the questions and got the answer. All the questions are previous year question paper. Try to solve these questions. Okay, thank you, welcome CNB Nalgonda. Thank you all, bye bye, take care everyone. Join your next class, guys. Yeah.